Okay, so I need to work the first practice problem for you. And it looks like we have two inclined planes butted up against each other. And this one has an angle of 25 degrees. And this one is 33 degrees. Resting on the left-hand side is the 6 kilogram mass. There's my pulley. My string passes over my pulley and comes down here and attaches to mass 2. And mass 2 is my 12 kilogram object. I have a mu over here that is 0.3, and I have a mu over here that is 0.15. And they want to know the acceleration of the system and the tension in the rope. So first thing I want to do is draw my free body diagram. So here's mass 1. It's resting on the ramp. There's the weight, and 6 times 9.8 is 58.8 newtons. Here is my Wy. Here's my Wx. And here is my force normal. And I'm going to call it force normal 1 because I have two different objects. Over here, I have a 12 kilogram object. It has a weight. Okay, and the weight is 117.6 newtons. Here's my Wy. And here's my Wx. This angle is 33 degrees. This angle is 25 degrees. I have tension pulling here. And I have tension pulling here. And looks like that's about all I know from my free body. Oh, I have a normal force here. Sorry. You got to have a normal force here. Okay, so now I'm ready to write my equation. So for the 6 kilogram object, I know that I have Wx down the ramp. I have force of tension up the ramp, so I'm going to make that be negative. So this will be positive, and this will be negative. This will be positive, and then anything down the ramp will be negative. And I have some friction here. Now I'm not real sure which way my friction is headed, but I know that this object is more massive. So I'm going to assume that my system is going to move like that. If it doesn't, my math will support that it doesn't, and I'll go back and fix it. So if I have the system moving in that direction, then friction 1 is going to be down the ramp, so it's going to be a positive value. For the 12 kilogram, I have Wx, and Wx is going to be negative because of how I set up my positive and negative signs. I have tension pulling up the ramp, so that's positive, and if the object slides down, then friction is up the ramp, so that will also be positive. I'm going to call it friction 2, 12 kilograms times A. I'm going to move this out of the way. All right, when I add those two up, be careful because this is for weight 1 and this is for weight 2, so don't cancel them out. I've done that before and it's not a good thing. So Wx1 minus Wx2 plus friction 1 plus friction 2 equals 18 kilograms times A. So now I'm going to go off and solve for everything. So Wx1 is going to be the sine of 25 degrees times 58.8. So if I punch that in my calculator, the sine of 25 degrees times 58.8, I'm going to get 24.85 for my Wx1. And my friction 1 is going to be mu times my force normal 1. Mu is 0.3. Force normal 1 is going to be the 58.8 newtons, because that's the weight, times the cosine of 25 degrees. So I'm going to take 0.3 times 58.8 33.8 times the cosine of 25, and I'm going to get 15.99. I'm just going to round that off to 16 because that'll make my life a little bit easier. Alright, now I'm going to go over here and deal with Wx2. Wx2 is going to be the sine of 33 times 117.6, because that's the weight of the 12 kilogram object. So the sine of 33 times 117.6 gives me 64. Newtons. And my friction 2 is going to be mu times my force normal, 2. My mu is 0.15. My force normal 2 is going to be 117.6 newtons times the cosine of 33. So when I do that, I'm going to take 0.15 times the cosine of 33 times 117.6, and I'm going to get 14.8 newtons for my friction. So it looks like I have everything for my equation up here. So 24.85 newtons minus 64 newtons minus, or plus I should say, sorry, 16 plus 14.8 is equal to 18 kilograms times whatever A is. So if I do the math, I'm going to take 18 plus 24.85 plus my 14, plus my 16. So let me check that again, 24.85 plus my 16 plus my 14.8, and I'm going to get 55.65. So I'm going to have 55.65 minus 64 newtons is equal to 18 kilograms times A. So I won't have a very large acceleration, but I will have an acceleration. It'll be negative, which means it's going to go down the right-hand side ramp and up. The other object will go up the left-hand side ramp. So 55.65 minus 64 divided by 18 will give me a negative 0.464 meters per second squared. So there's my acceleration. Now I need to go back and work through and find my tension. So I'm going to pick the bottom one because I can see it clearly. Negative Wx2 plus Ft plus friction 2 equals 12 kilograms times A. Negative Wx2, my Wx2 was 64, and I need to make that be a negative 64 newtons, plus my tension force, plus my F2, which is 14.8, is equal to 12 kilograms times A. So, and I know my acceleration, so I might as well substitute that in there. It's negative 0.464 meters per second squared. So now I'm going to get my Ft. So 12 times my negative acceleration, and then my negative 64 comes over and is a positive 64, and then the 14.8 becomes negative when I move it over. So I got tension to be 43.6. But I want to go back and double check and make sure that I didn't make a mistake. So 12 times negative 0.464 plus a positive 64 minus a 14.8. Yep, I did it right. Okay, that'll take us through one. The other ones are posted on the Edmodo page.